Hello, ladies and gentlemen, and welcome to another presentation at the Annual Corrosion Forum 2022. Um, this next presentation is going to be given to us by Urvesh Vala, and it will be on the topic of selection of coating materials in oil and gas industries and use of advanced coating processes for corrosion protection in present and industrial scenario. But before we start, we're going to give a brief background into the presenter. So, Urvesh is presently working as a head of materials engineering and technology at L&T Chiyoda Ltd India, and his current contribution to the engineering societies are he's a chairman of Society of Metallurgy Engineering at MS University of Baroda, vice chairman of Indian Institute of Metals Vadodara, India, NIGIS governing board member for NACE India, appointed as advisory board member of Indian Institute of Welding, executive committee member of ASM International, Gujarat, India, senior research fellow at New Delhi, and he has also published over 80 research papers and presented at international and national journal and conference proceedings. He's also won the award with the NACE International Award for Best Paper in the Symposium of Coatings and Linings at CoreCon 2017. He's currently pursuing a PhD in metallurgy engineering at university. He has an ME metallurgy engineering, a BE in metallurgy engineering, and also 25 years of experience in industry, including steel manufacturing, PMC, EPSC for oil and gas refineries and petrochemical complex. So I'll now pass you over to our presenter who will continue on with this presentation. Thank you very much today.
Okay, thank you. Thank you, Institute of Corrosion, for introducing me. It was nice introductions. Thank you for that. Over to my topic, that is on selections of coating material in oil and gas and petrochemical industries. What are the advantages of this and how we select the coating? Just to have a content of my present talk, I'm going to talk about why corrosion control is required. Few examples of corrosion, causes leading to corrosion, consequence of corrosion control, design and fabrication requirement of coating, basic of industrial coating, types of coating in detail, compositions of coating, how it is mixed and what are the types, method of coating applications, how it is applied. We have interesting videos where we do coating, so you can have understanding how it is applied. Then corrosion protections, how it will protect the surfaces. Then selections criteria for coating, and also for underground coating requirements. What are the types of underground coating? What are the characteristics of plant coatings in present scenario, and typical coating systems for oil and gas in general with pictures so that you can visualize how coating can support environmental and process corrosions. Coming to the topic, why corrosion control is required? Because of the economic aspects. In recent scenario, the cost of corrosion is direct and indirect based on the types of industries which we are talking, oil and gas. So economical aspects, if corrosion is there, failure due to corrosions is directly, indirectly costing the end user and the society. It is a health aspects, like wherever there is a hazard or there is an accident, there is always challenge of humans, and humans are always challenged based on the severe corrosion damages in the oil and gas sector. Then cultural aspects, yes, of course, whatever failures due to corrosions is going to be very difficult for the society to accept those things in terms of human life loss. Safety aspects, yes, of course, it is going to harm the humans, and it's always our first priority to have a safety during or in process equipment inspections and monitoring activities. Now coming to why I am going to introduce this topic, the examples of corrosions. These are the things where we see that if we don't address the things, it is going to be a very heavy corrosions. This is the tubes of the furnace. This is the offshore platform. It is not painted properly. And this is all the process pipelines where you find very heavy decorrelated product over the flange joints. Now, coming to the more critical aspects of corrosion under insulations, when we remove insulations and when we see the coating, if you see the coating, it just peel out. That is what the signing of poor insulation over the surfaces. Similarly, if you see the platforms, it's get corroded because of the corrosive products there. So corrosion on onshore skids are also a problem for aesthetic appearance as well. Now coming to the corrosion problems, which is there in industry, it is everywhere. It is in the offshore platform, onshore platform. There is a splice zone area because of the high tide and low tide. The corrosive products are accumulated over the surfaces, and because of that, it is get corroded very fast. Then the desired life of the component, and you find such failures are there. And even on the running ship, the ship hull, because of the spillages of the seawater is going to deteriorate the coating life. So these are certain examples where we can see that the corrosion is the major issue in ongoing industry. This is one particular boiler plant where you find the heated zone here. So wherever more heating areas are there, it get prone to corrosion. Similar way offshore platform, that is the windmill tower support base. You find that near the whale at the joint whale joints, you find corrosions. All the whales are prone area for getting more corrosion. And there are certain water spillages or due to some restrictions over some structures, this get uh, heavily rusted portions in under the sea conditions. There are many other causes leading to corrosions that is not limited to the operating temperatures, design temperature of any particular structures which we are think of. Painting is also important. When we see operating temperature, it's always important that paints are selected based on operating temperature requirements based on the process fluid. Yes, of course, very corrosive media. You have to select corrosive category to the extreme high corrosion resistance based on the gases or corrosive products which we operate. For example, S2S, CO2 chloride, organic compounds are the major concerns for heavy corrosions or severe corrosions in the system. There are severe ambient conditions are there, hot and humid climate, seawater nearby structures. Refineries, petrochemical complex are always a challenge. So it is always near the seashore for the oil which they want to process to convert into petrol, diesel and usable form. So it is always there near the seashore, and challenges of the chloride environment is the concern. Improper design, yes, of course, there are certain if and buts for the designer. They have designed certain things where stagnant zones or corners are there, or the joints which is required is not at a higher radius, and because of that, it's the impeachment of process fluid leads to heavy corrosion. Even there is low quality equipments and material if you choose based on the cost optimizations requirement. There are also certain compromises and codes restrictions by which you can have some impurities as an acceptance criteria leading to corrosive failures in industry. There are certain microbial actions. Yes, of course, if the water is stagnant, most of the case fire water network where water is in the stagnant conditions and there are certain bacterial growth. Maybe there is SRB, that is sulfur reducing bacteria are prone to give very heavy corrosions on carbon steel pipelines. Now coming to consequence of corrosion control, material selections and corrosion control for given applications is one of the main design steps towards safe and cost-effective system selections. So this is very important. If your material is not having good strength and its resistance property with respect to corrosive environment is leading to premature failure. So that is very much important for us to know. The benefits for doing this is we can uh, save our asset uh, and we do asset integrity management very well by selections of material. Optimize performance with minimum maintenance and shutdown. So that is again a second advantage for us to know. Longer life expectancy, because if you see select proper material, proper corrosion control methods, it gives longer life. Cost saving, yes, of course, if we select the material and coating, it is going to give better life more compared to uh, the maintenance cycle of things. So if we control this, we can control more active acidic corrosions. If you see the picture of the pipe, it's get heavily rusted and get destroyed its life. What is the scenario? If you see this, normally this is because of gas phase and liquid phase corrosive environments, which is there inside the pipe. So if there is a sulfur which is there or sulfide is there, it is get converted into hydrogen sulfide with the help of this sulfur and hydrogen reactions. It generates H2SO4, that is sulfuric acid. So it's going to be a very acidic, and because of that, pH goes down near to 2 and 3 in the number, and because of that, it prone to corrosion. So this is how the acidic corrosions are normally addressed. So we want to control this with the help of many coding applications. We can do internal lining. So based on that, in present scenario, S2S can be prevented by coding. Now, how these designs and fabrications requirements for coatings can be understood, that is based on the preparation grade standard, that is P1, P2, P3, which is based on ISO 8503-3 requirements. Here, the category is given based on the service durability, and that gives good value for the coating which we select. The more the better surface preparations, more the quality of coating and life of the coating. If the preparation grade is P3, that is very high and very highly distributed case. C4 is the corrosive environment. So C4 and higher, then it gives good surface finish. Even immersion category, that is IM1 to IM4, that is also give you a good understanding about design of any particular coating in the corrosive area. Areas required special attentions based on ISO standard, that is hard to reach or inaccessible areas. So blasting or the mill scale removal is the challenge. Other is the rivets, bolts, and other connections where crevage is going to be formed. That is also a challenge for us for giving more life of the coating, as we see in the pictures before. Other is the weld gaps, what I say in the offshore platform. Weld is the area where if you apply the paint, this is prone to get corrosions because the paints is not stick to that particular surface very tightly. It is not adhered to the surface. Other is overlapping surfaces, roof plate on the wall tanks. Normally it is have a cantilever shapes. So those things are again a problem for us to have a proper coating. Angle ions badly oriented or in complex arrangements, that is also going to give us poor coding applications. Threads area, always a challenge because after paint you do a bolting, tightening of the bolts, it's going to eat away the coding on that particular thread parts and is prone to corrosion. Diamonds, dissimilar metal. This is again a big topic for us to address. Dissimilar metal, I can talk a length. There is one hour lecture we can give only on dissimilar metals, as this is the only area where you want to protect more noble by doing painting on the surface. This is just a one takeaway for this lecture. Other is sharp edges, particularly on corners and rough cut plates. So those area, we have a subsequent slide where I will address this point again, that sharp edges and the corners are always having lesser DFT, that is called dry film thickness over the surface. And because of that, it is going to be a problem for longer life of that component, and corrosion start from the edges. Again, construction errors. Normally, the construction errors are always to be addressed when we design fabrications for any coating systems. Now, this is one slide from ISO 8501-3, which says table 1, acceptable imperfections with respect to preparation grade. P1, P2, P3 are the preparation grade. P1 is least surface preparations required based on the welding parameters. This is one a sample. You have a more in table 1. There is a big list of things to be addressed during surface preparations. P3 is the best surface preparation grade. So ideally, we recommend to have a P3 surface preparations so that weld spatters can be removed or it will be eliminated. The weld ripples or profiles, you get a smooth surface so that paints can stick over that. Welding slags are almost get removed if you go with a higher preparation grade P3. Undercuts always get built because of the high pressure abrasives applied over the surfaces. Weld porosities can be locked, which is open to the surface. So these are the certain things which if we address, then we can avoid certain pockets by which the paints get peel off faster than its life. Coming to certain poor design examples, this is what the structures are. Normally bolted structures always have certain gaps. So these gaps are prone to corrosions. There is certain things where there is a laminations defects in the plate material, which get peeled off after painting or sometime during services for certain structures. Certain splatters are there, which is the welding error. So they are not removing the things. They don't dress up the joint properly. So this is prone to early corrosion. Again, poor design. These are the flush joints for the weld, and other side is also same. And this is what the gap is. So this gap by which the corrosive product get inside and accumulated and form localized crevice, and it create premature failure of the components. Similar way, if you see the flange joints, because of the leakages due to the poor tightening or there's a mismatch between the gasket face to the flange face, it's get leak out, and because of that you find heavily rusting over the bolt joints. Or sometimes dissimilar metal weld or dissimilar metal joints, we can say the bolt material and the flange materials are different. Because of the gelling effect, they always choose low alloy steel material for stainless steel joints because of its high strength, and that is leading to poor design based on the corrosion resistance properties of the bolt. And sometimes it is difficult to even open during shutdown. Similar way, if you do the welding on one side, you left unattended welding on other side, is going to create problems with the structures. Same way for the corner joints, as I said, it is prone to early corrosions because of the reasons as shown here. If we apply the paint on the very sharp corner, it's not going to stick much paint over that corner. And because of that, it is going to give you premature failure like this as shown in this. So what do you want to do? You just make certain tapers 3 degree so that the edge get radius, and because of that, the DFT, the dry film thickness, is more as compared to the traditional one, and you get a better life of the component. So small things, if you address in terms of design, you will enhance life of the component. Here you don't do any miracle, but only you have to make a 3 degree taper for the corner joints. It is going to kill your premature failure of equipments. This is another example where we say that there is a certain riveted joints. So riveted joints are always forming crevice, and because of that, it got much faster corrosions than what we think. So nowadays, this is now replaced with the welded joints. Coming to all these things, then how industrial coating can be selected? What is the basis which we think of? So let us come to know the types of liquid coatings. So that is normally or broadly classified into two categories, organic and inorganic. So by name, it is going to be a differentiate between each other. Organic is at a lower temperature. Inorganic can withstand slightly higher temperature. All the products which is there in the sea, like a ship and all, is coated with the organic coatings, and inorganic coatings where we have a challenges based on the temperature. So most industrial and marine coatings are of organic coatings. So it is always there for lower temperature. Normally that is made from living or once living things. And it is the old technology, is the 1900th century term, and these things are under existence. So it's not new what I'm saying about the coating. Organic coatings are vegetable or animal oil uh, pigments, and normally it is used for petrochemical products, productions, joints, the equipment's coating. Other is organic coatings that is normally contain carbon as a impurities. Inorganic coatings are the more popular in oil and gas, that is having binder, most commonly based on silicon or silicate. This is the base by which the paints are known, their name, silicon base or silicate base. The major difference between organic and inorganic coating is the heat resistance. What I say that inorganic having more heat resistance than organic coatings. Organic coatings that have laser resistance because of the relative weakened carbon to carbon bonds. Because of that, it is normally good for the low temperature applications, whereas inorganic coatings have a more applications in oil and gas applications. Now, people will want to know that what are the components normally coating having? We say coating means one layer, two layer, three layer, multi-layer coating. No, it is not so. When we want to buy the coating, there are many components which is contributions to the coating, liquid applied coating components, normally pigments. This is what the pigments name is given to the coating. Resin or binder, which is added to get those over the surfaces. The sprayed area ratio with respect to different coatings is designed by this. Solvent, it is just giving you the applications, and after applications, solvent will vaporize and it get into the environment and you find dry film thickness. So there is two terminology, wet film thickness and dry film thickness. So wet film thickness is with all these components as listed, pigments, resin, and solvent. When solvent is get removed from the paint in the environment, whatever is remaining is a pigment, and that pigments is nothing but is a dry film thickness of any coating. So this is all the vehicle is. Vehicle means is a resin and solvent. So these two, if you bind with the pigments, these two things are get out of the system, and whatever pigments are there, it is nothing but is a life of that particular coating. Or you can say that it is the only component by which you can get the dry film thickness. Generally, the ratio is 20% so that you have a proper dry film thickness over the surfaces, or DFT in terms of microns is that can be achieved. Now coming to the methods of coating applications, that is airless spray. Normally, I just give you one example. Airless spray is the spray where you can apply the coating, but generally airless spray is not good for zinc silicate primer. For that, you have to use spray gun, which is not airless type. So that is one takeaway for everyone, because same gun cannot be used for priming and subsequent coat. Then conventional spray, that is by the brush or by the roller, that is also a possible way of doing this. Other is that is brush and roller with the mechanized system, airless spray. Nowadays, robots are there in the picture for us to know. Now I will let you know to certain videos. Just view this.
In a good spray pattern, the paint or material sprayed is completely and evenly distributed onto the surface. In this video, we'll cover several techniques you can use to ensure a quality finish. In this section, we will discuss spray patterns, spray techniques. Before starting your project, if you don't have a lot of experience with spraying, use some scraps of cardboard to test the quality of the spray pattern. You could spray a large flat area, like the side of a house, that's not easily seen. Or you can practice with water. Just make sure you let the surface dry completely before applying your paint. As you're practicing, start at the minimum spray pressure and slowly increase the pressure until a good spray pattern is achieved. This is a good spray pattern. Notice that there are no runs in the pattern and that the pattern itself is smooth and even. If your pattern has what are known as fingers or tails, an uneven finish, such as this, then the pressure should be increased. Spraying at the lowest pressure possible while still getting a good spray pattern will save wear and tear on your pump and spray tip and reduce overspray. If you're at the maximum pressure setting and the spray pattern is still not suitable, a smaller tip hole size should be used or your material may need to be thinned. Follow the instructions on the back of your material container under spraying applications. The gun should be held approximately 12 inches from the surface and aimed straight at the surface. While moving vertically or horizontally, the gun should remain at a consistent distance from the surface. Fanning the gun to direct the spray at an angle causes an uneven finish. Flex your wrist at the beginning and end of each stroke to maintain an even coat. Don't spray at an angle. Keep the gun perpendicular to the surface. To practice proper gun positioning without spraying, try moving the gun and holding it perpendicular to the surface, only about 2 inches from the wall. Notice how at the beginning and end of each stroke, you'll flex your wrist to keep the gun square to the surface. Move out to 12 inches for additional practice. Work in sections only as far as you can comfortably reach. First, spray the outer edges and cut in any corners. Then, aim the gun at the edge of the previous spray pass so the spray pattern is actually overlapping each pass by 1/2. Trigger the gun after starting each spray pass and release before ending the spray pass. Your arm should be moving when the trigger is pulled and released. This will create a nice fuzzy edge around the entire spray pattern so your next pass will blend into the previous pass. Rotating the guard changes the pattern to either vertical or horizontal orientations. When spraying on broad open surfaces, such as ceilings and bare walls, the outside edges should be sprayed first, then the middle can be sprayed more quickly. For vertical corners, turn your guard so the spray tip is on the top and aim your gun into the corner. Spray along the corner, applying an even amount of material along both sides. Typically, when painting, it's best to start at the top and work your way down. Begin by spraying any eaves or the underside of overhangs. The direction you spray is determined by the construction. As a general rule, spray horizontal and make sure you direct the spray up a little to spray the bottom lip of your siding. With a little practice, this easy-to-use sprayer will have you spraying like a pro in no time. Remember, point the gun straight at the wall without tilting up or down or angling left or right. Start moving the gun before and after you trigger. Move at a consistent speed, and when spraying, overlap the prior spray pass by 50%. Allow enough time for paint to dry before removing tape from your trim. This will result in crisp, clean lines.
So this video says about airless spray, how it is to be applied. The pressure of the tip of the gun is around 7 bar or 7 psi. That is the pressure which is required for us to maintain so that it gives a proper spraying and it is going to be lesser wastage of the paint. So it will apply directly over the surface. The video says about the wall. We always think for this based on our applications. So guidelines which is there is common for the steel equipment or for the structure. This guidelines is for how to apply and how to maintain the airless spray distances and how it is to be applied. 50% overlapping is the requirement. So this is what I take away from the video. That this next video says about how the sprays that can be applied over surfaces, and just listen that and then we will discuss.
It may seem like a recent invention, but the act of spraying paint has been around for thousands of years. In fact, Stone Age man used hollow reeds to spray pigments to create cave art. But just like most technologies, spraying has evolved and advanced over time. Today, there are 4 main types of spray delivery methods. Air spray systems use highly pressurized air created by a compressor to atomize the fluid being sprayed and deliver it onto the work surface. High volume, low pressure, or HVLP systems also utilize compressed air, but in a different way than standard air spray systems. With HVLP, a turbine delivers a large volume of air at a much lower pressure to atomize and spray the fluid. Airless spray systems need neither a compressor nor a turbine. Rather than rely on air, these systems use a pump to deliver fluid at high pressure to the spray tip. They deliver fast speeds, and they spray the widest variety of materials. Air-assisted airless systems combine airless and air spray methods. An airless spray fan has compressed air added to soften the spray fan. When it comes to achieving professional painting results, being able to quickly apply the coating you're using in an even, consistent manner makes all the difference. Airless spraying allows you to do just that. Plus, it's faster and easier than using a brush or roller. In fact, using an airless sprayer is up to 10 times faster than using a brush and at least 4 times as fast as a roller. So, how is it done? Airless spraying achieves this speed by atomizing or breaking up the fluid into small droplets without the use of compressed air. Instead, fluid is pumped under high pressure through a spray tip. The fluid emerges from the tip as a high-speed solid stream, but when that stream hits the air, it becomes disrupted, and the fluid separates into very small droplets that form the spray pattern. If you've ever placed your finger over the end of a running garden hose, you created a very simple form of airless spray. Since 1958, when Graco invented airless spraying, professional contractors have preferred this method of spraying for many reasons. Speed. Because airless spraying is faster, more jobs can be completed in less time, using less labor. Plus, it's great for jobs with a short weather window. Quality. Airless sprayers produce an even coat of paint, referred to as the mill build, on all types of surfaces, leaving a high-quality finish. Versatility. Airless sprayers can be used for a wide range of coatings for both interior and exterior jobs and can easily be transported around job sites. So, what is airless spraying? Simply, it's the fastest and most versatile way to achieve professional painting results.
So the things are like, what is the difference between air versus airless spray? Airless spray is having a lot of merits. Even this is based on the brush and roller. It is going to be very productive in terms of time, and it gives you very good spread over the surfaces and you better DFT, that is called dry film thickness, uniformly over the surface. So that is one takeaway for this video. Now about the other things where the corners are there, where we can paint the things. So these are all top coats requirements, which is with the help of roller or brush. And this can be addressed. This is not addressed by the spray. So that's it from this thing. So these are the things which is important for us to know. All techniques are important. They have their own merits and the plus and minus, we can say. And based on that, we have to apply this for our applications. Now coming to the corrosion protections. So with all these techniques, if we apply the things with spray or sprayless or with a roller or brush, but what it will do to the job, it is going to do corrosion protections. It is by four way. One is a barrier protections, other is inhibition or inhibitor protections, sacrificial and combined. Either it is combined two or all three together or any two of barrier or inhibitor and sacrificials. So B stands for barrier, I stands for inhibitor, S stands for sacrificial, and C stands for combined. So that is what we are going to select coding based on many criteria for us to select. So the criteria for coding is first is the substrate material, or you can say the base metal. Whether it is a carbon steel, is a stainless steel, is a hot dip galvanized steel, or is a non-ferrous aluminum surfaces. So any surface you can do coding. For example, aircraft is of aluminum, lithium, copper alloy. So you find good coatings over the aircraft. So that is nothing but it's a coating on the aluminum. Hot dip galvanize all our pipelines, which is for fire safety lines, is painted, which is of the hot dip galvanized steel. Stainless steel and carbon steel equipments pipings are painted based on several reasons. Carbon steel, of course, because it's get forming an oxide over the surface, so coating is always good for increasing the life. Stainless steel is normally painted because of the reasons. That is nothing but chloride, stress corrosion, cracking, minimizing. So under insulation, stainless steel is always good to paint, or you have to put aluminum foil, which is going to isolate the insulation chloride environments, or there is a gap in insulations and which is going to create problems on stainless steel surface with respect to time of that particular improper insulations gaps, which leads to premature failure of stainless steel pipes. Other is service conditions, operating temperature normally open to atmosphere. This is what the maximum case of equipments. So normally all the refinery equipments are in the environment. So open to environment or open to atmosphere is the requirement, which is very important for us to know. Here under insulations, that is more important, rather it is not looked to us. So there are many non-destructive testings are available, which can identify corrosions under insulations. So that is the second things. For CUI, there is a special NACE standard, NACE SP0198, which says how to do coding for under insulation applications or under fireproofing applications. High temperature is again a challenge because the maximum upper temperature limit is 650 degrees C for any painting selections. So beyond that, there is no much corrosions because there is no much water phase available for reactions. So there is no much corrosion expected. So even carbon steel we can put without coating, and no coating will have life at that particular temperature. Other is cyclic service. Yes, there is a very versatile paint which is called inorganic copolymer available, which is normally a versatile solutions for cryogenic temperatures to high temperature. So minus 196 degrees C to plus 650 degrees C. One paint is the solution that is called inorganic copolymer paint, which is very popular nowadays in oil and gas industries. Other is expected life of coating. That is also a major criteria for selections. You can protect your structures for 10 years, 15 years, 20 years, 25 years, or more than 25 years. Nowadays, there is a standard which says more than 25 years of life of coating. It is normally called TSA. That is thermal spray coating. That is what the metal coating or metallizing, which is there, and it is having more merits in present scenario for offshore platform rigs. Then feasibility and frequencies of maintenance, that is also a criteria for coding selections. If you are having frequency lesser in terms of number, or you can say the cycle time is higher, say 5 years, you do one particular coding DFT, diaphragm thickness, which gives more life. If it is lesser, if it is a 1 year or if it is a 2 year, you have to change your coding system and you can refurbish the coding based on the life of that particular maintenance. So your asset integrity teams are the team which is deciding this particular cycles for maintenance. HSC requirements, that is a statutory requirements, yes, of course, where there is a toxic gas, there is a HSC involved, we have to be very strict on equipment design as well as coding type, because there are certain paints nowadays available which tells you when it's changed the color, that means that corrosive gases are in the environment. So those are the indications for us to address the coding. So these are very good topic for us to address, because this HSC requirement we can discuss in length, and is a very good merits nowadays for understanding the discolorations, or there is a change of colors based on the gas which is coming out of that particular pipings. Now recognize standards for different services which is there, like ISO 12944-5, that is normally there for the environmental coding requirements. Similar way, NACE SP0198, what I say, it is for corrosion under, or you can say under insulations paint or under fireproofing paints, which is normally categorized into NACE SP0198 system, coding system. So these two standard, if you know, you can select any coding based on these two codes, which is above ground or under the environment, or which is underneath of any insulation or fireproofing. Now coming to comparison compatibility chart, you can have a compatibility that is X and Y, epoxy to epoxy, you can say yes, Y is a yes, N is a no, and Y with the remarks is you have to refer the notes. So you can have a good comparisons for any particular pigments, which we say epoxy or coal tar epoxy or epoxy mastic, or you can say alkalides, silicone alkalide, polyurethane, or you can say bitumens, any particular paint. Vinyl ester is again having good properties based on higher DFT. Then phenolic epoxy. So you can compare any paint with any, and you can choose the combinations of two paints for your applications. Yes means yes, you can do, no and say no, so you cannot use. So there is a called system that is single pack and multi-pack. So based on those, this particular charts are designed. Now coming to corrosive environment category, which is listed as per 12944-5. I just repeat, 12944-5 is the coding design requirement, whereas corrosive environment category is by -2. So whenever there is an environmental related corrosions, C1 very low, or what AC environment which we are sitting normally on, it's categorized into C1 category. If you go towards the corrosive environments, it's increasing in C2, C3, C4, C5, which is very high corrosive environments based on industry. It is near the seashore. It is a corrosive industry, chemical industries, petrochemical complex, all categorized into C5, very high corrosive category. Similar way for immersion services, IM1, which is for the fresh water, means there is no much corrosions because of the good quality of TDS, which is there in that. That is what the sulfide, chlorides, or other solid ions, which is there, which is carried by the water. IM2 again is a CU or brackish water, which is without cathodic protections. CP means without cathodic protections, because under the immersion category, buried category, so it is always having a CP, cathodic protections, in many applications. And if the soil is having very high soil resistivity, cathodic protections can be eliminated. So this IM2 is the category for that particular services. IM3 is for soil, where we have a soil with all high resistivity. IM4 is a sea or brackish water with cathodic protections, where you have a more chloride, more sulfur producing bacteria are there because of the types of water or soil properties. So these are the categories mainly defined for any industry, above ground, underground services. Now coming to corrosive environment category, that is what we say C1, C2, C3, C4, C5. So this is again going to give you the above ground category. IM1, IM2, IM3, IM4 is for the emergency service category. So this is just for us to take away for the lecture is whenever somebody says C4, C5 is what the heavy corrosive environment. Similar way, IM4 is for the CP. Now, this is what about the corrosivity. Now, the durability. Service durability is nothing but is a life of your coating which you select. That is also based on ISO 12944-2. Durability, if it is low durability, is up to 7 years. So you have to apply paint, which life is 7 years. Medium is again 7 to 15. High is a 15 to 25. Very high durability means it's a good quality paint, more than 25 years. But of course, you have to take care of many design aspects which we discussed before. Now coming to dry film thickness requirements on onshore based on ISO 12944-5 requirements. We have a low, medium, a high and very high durability. Based on that, whenever we select any primer or combinations of any particular primer based on the types of what we select based on our corrosive category. We have not specified here C1 because C1 is normally the inert environment. So we don't listed those. So C2, C3, C4, C5, based on that, how much DFT you can get. M DFT is a nominal DFT. M is a minimum DFT. So based on this, we have to make our dry film thickness comparisons or the design. And this is for new durability category, new DFT values when we apply for the first time. When we apply for a repair is a different table altogether which we have to refer for. Now based on typical design temperature range of coating, that is based on the temperature, alkalides having temperature range. The dark color and the light color is for the direct exposure and one is for the short-term exposure. So based on that, the range is specified. So you can see silicate, which is having a silica as a base, or silicon, which is which can withstand very high temperature or even cryogenic temperatures. So this is how we can say bitumen, which is normally used in the buried applications, which is not so higher in temperature range because it is the type of paint which you have to use for lower temperature range. Now coming to underground coating, there are traditional specifications for coating for plant piping as listed based on the product type, straight pipes, welded joints, miter bands, T and taps of buried valves, buried flanges. So based on the product form, there are various standards available which we can compare and get the informations what types of coating which we have to do. For example, if we have a straight pipes, that is a plant coated CTE, that is as per AWA standard. AWWA is a standard, and this is AWAC203 or IS 10221, that is based on Indian standard, and BS, that is a British standard 4164, which is applied in the range of 4 mm thickness. 4 mm is nothing but 4,000 microns DFT, or you can use DIN standard. This German standard that is also 30670. You can apply for such particular straight pipes, and it is normally the soap applied paint, and it is having more popular things as we can see. Other is hot bitumen tap, which is normally there, or coal tar tap, which is there for valves and fittings, which is we can apply it at the site or even at the shop. Similar way, you can have hot bitumen taps, which is up to 4 mm, or cold applied tap, or cold tar taps you can apply for 4 mm thicknesses, which is available for all other products, bands, tees, valves and fittings. Now coming to traditional coding. that is polyuniform coatings is a 3LP, 3-layer polyethylene or 3-layer polypropylene coating. Or you have a different plies, 3-ply and 2-ply. Is a 2-layer, 3-layer coating. So these are the categories which is in this forms. It is field applied, which is having a good, both is having a merits. It can apply on the field. It can be applied on the factory and the field. So wherever there is a good quality in the shop over the straight pipes, you can apply 3LP, and at the field you can use 3-ply and 2-ply coating. So this is a combination of coating which you can choose for the temperature range. This can be used up to 120. This field apply can having restrictions of 50 degrees centigrade. Normally it is for buried applications. The thickness range, which is in the form of 2 to 3.3 mm based on the applications. Good impact resistance because it's having good impact for site conditions. High indentation strength because of the leading down the pipes. Cathodic disbandment resistance because of the cathodic protections requirements. It can be read based on ISO 12809 part 3 for 3LP and 3LPP coding, and same way EN 12068 for 3-ply and 2-ply codings. So these are the standards which tell you in detail about the coding, and you can read and get the information. You can reach out to me if you have any questions. Other coating is called liquid coating, or it is applied with the pigments, what we see before. So it is always field coating that is applied with the help of brush spray, or you can apply it only by the spray if it is polyurethane. If it is high build liquid epoxy, which is having higher DFT, that can be applied with the help of brush and spray at shop and site. Normally site is use this technique more because easy to apply over any elevations. So any length of pipes, maximum temperature resistance is 150. Thickness range available 0.6 to 1.5 mm, and all the properties are same as before. So good strength, impact, indentations, and cathodic disbandment resistance. So these are the things which is important for us to address for the liquid coatings also. Now 3LP coatings, how it is looks like, how the process is. The bare pipe, you applied the first layer, there is a primer, then you have to apply adhesive material, that is the second layer, and then you have to apply polyurethane or polypropylene. So based on this particular types of coating, it is called 3LPE or 3LPP. So this is all based on the applications and temperature requirements for selections. Coming to 3LP process, normally pre-cleaning, then abrasive blasting, then preheating, then first layer applications epoxy powder, then second layer polyethylene adhesives, third layer is the polyethylene or polypropylene, so by which you can close this particular process. Only limitation is this, that it is only applied in shop, not in the field. And you have to do cooling. Yes, of course, because it is a hot process. So at the end, you have to do cooling so that tap get settled over the pipe and it gives good adhesiveness properties. So this is all about 3L, PE and PP. How to go for ISO 21809 requirement for external coating in terms of buried submerged pipeline applications. There is a 3 class A, B, C based on the top layer material, that is LDPE, MDPE, SDPE, and PP. PE stands for polyethylene, PP stands for polypropylene. So these are all combinations of polyethylene and polypropylene material resistance based on the design temperature of any particular coating. So -20 to +50 or +60, this is the range. The second B category is slightly cooler or is in the cryogenic temperatures to say 80, and polypropylene can withstand very high temperatures, say up to 110 degrees centigrades. So that is all possible for us to go and read the standard. So 3-layer polyethylene and 3-layer polypropylene, temperature resistance is not much. more than 110, it is not generally used because of its applications to use in underground applications. So coming to the next coating, which is having merit, that is called FBE coating, fusion bonded epoxy coating or liquid coating. You have a bare surface, you applied the FBE coating. So there is one and second layer, which is a soap applied, high production rate you can achieve. You can do automations in the systems. What are the steps for this? Again, is a similar like what we have for 3LP, 3LPP, pre-cleaning, abrasive blasting, pre-heating, FB applications, and curing. So this is how the things are moved. And lastly, of course, testing that is got good bonded over the surface. So this is how the cycles are moving and we have all the steps till dispatch. The next layer coating for underground is 2-layer tap coating. So this is what the coating is, how it looks. This is what the machine or the applicator can do applications and they are just moving this over the directions of the coating. So it's progressing from this to this side. So this is what the soap and field applied coating. It's a low production rate because it's a manually you have to apply or you can do semi-automatic applications. So based on this, you can apply this particular coating that is called 3-layer tap coating, having process or pre-cleaning, abrasive blasting, primer applications, and then P inner tap coating and P outer tap coating. That is what the things, and then after the testing for the quality check of additions. So this is how the things are addressed in coding inside and at shop. So liquid coating, that is high build epoxy, liquid epoxy and polyurethane. The temperature for polyurethane is 60, whereas here is 150. So is having high temperature applications. This is having a by brush and spray. So easy apply. This is only by the spray. And other parameters are almost same for all for the cathodic disbondment, impingement and indentations property. Now this is very interesting. There is 3-layer heat shrink sleeve. Normally when the pipes are coming in two parts, is to weld at side. So this is nothing but is a weld. And then to join this weld, we put certain heat affected zones and some balance area for coating to apply. So it's generally in a thumb rule is 100 mm or 150 mm both side of the weld so that you can have a proper coating for already coated pipes. So you just put 150 mm one side and whatever pipe you have that is called 3-layer polyethylene, 3LP. And the joint which is there is by epoxy coating. And that is the first layer. Then you have to apply adhesive. Then you have to apply polyethylene and polypropylene backup. This is in the range of 2 to 3 mm. So it's very high quality coating which we can have for any side applications requirements. So this is the process itself is called heat shrink sleeve. This and normal epoxy coating applications, this is a costly one. Now T-joints, bands, flanges, spools, walls, which you have to do at site. This is all the coatings which is done in the shop and then it comes for this particular joint building. So now after this, we have to do certain welding, of course, because we cannot leave this as it is. So there are certain irregular shapes, which is under transitions, or you have to do welding at site. This particular things is not carried out in shop, so it is to be applied at site with the help of coating. That is field applied coating. That is 3-ply or 2-ply coating, or you can apply liquid coating. Or nowadays very popular is viscoelastic tap coating is there for us to address for any side applications joint. So this is how we can get into the good quality paints at site. This is just a comparisons for what we have done so far based on the operating temperature, applications, surface preparations, chloride contaminations and soil characteristics. 3LP is 80 degree, high build epoxy 150, 3-ply, 2-ply 50, viscoelastic tap 120, and 3-layer heat shrink is up to 80 degrees centigrade, and other is the surface preparations as listed here. SA 2.5 is a Swedish standard. It is normally giving 60 to 90 micron roughness over the surface, by which paint can adhere to the surface profile. So it gives you very good locking for the primer and subsequent coats. Chloride range is always, of course, a challenge, but viscoelastic wrap tape, there is no limitation. So you can apply this in field, and this is having good barrettes at 120-degree temperature. Now coming to the selections, typical coating for buried applications, what is for what? You have a straight pipe, you can use all the types which we discussed. If you have a T-band, or if you have a weld joints or buried miter bands, there is a restrictions only for the 3 processes, that is epoxy coating, 3-ply and viscotap, because this is at the field applications requirement. So these are the field applications. 3-layer heat sinks again is the field application. So all these things we have to do at field. So there is only limitations of this. Only straight pipe and compatibility with respect to cathodic protections is achieved for all the joints because it is for underground applications. So this property must meet for all the coating types. So this is which is good for straight pipe as well as for all other processes which we have already discussed. Now this is one example. I am just putting you the questions to all the participants. Like I have all the painting coding requirements. You can see that one is 3LPE. Then I applied certain epoxy. Then I applied 3-ply, 2-ply. And if I combine all these coatings together and I will just close the surface, I just want to answer from all of you that which coating give more life based on all these different coatings what we learned. Please write to me once you understand the code standard which I have shared and understand how the things is to be read based on life of coating which we have to select for UG applications. Now I'm going to give you some interesting photographs for my journey in my company, where we have a typical coating systems which we select based on oil and gas and chemical industries requirement. Structures, we can see that inorganic zinc silicate plus epoxy plus polyurethane. Polyurethane is PU is applied for UV resistance, ultraviolet ray resistance, or you can say under the sea, under the sun sign. This is what the important is. This is what the color of any particular coating. If you say yellow, blue, green, is not because of all these things, it's because of this polyurethane. Pressure vessels, again the same stack, again because boiler operate at high temperature. So zinc with silicon, aluminum. Now we can say zinc melting point is 420 degrees C. So if you put this with silicon aluminum, it enhances the coating life to 650 degrees centigrade temperature. Stainless steel vessel, of course, you cannot apply zinc because low metal embrittlement is the phenomena on stainless steel surfaces. Because of that, we always used pigments which is silicon acrylic base or silicon aluminum base for stainless steel vessel. Even for blasting, painting, the things which is there for stainless steel is slightly different than the carbon steel equipments and vessel. Reactor again at high temperature, epoxy phenolic. Storage tank, that is again 3 coats external plus solvent free, epoxy internally, because solvent free means it is going to give you more solid. So there is no much solvent available, which is going to evaporate. So higher dry film thickness, that is for the storage tank internal. Then load bearing support, which is fireproofing coating, which is normally there for resisting fire protections material. Normally concrete is the one fireproofing material, then lightweight vermiculite, and intumescent paint is categorized into this fireproofing coating requirements. Piping, always we understand 3LPE, 3L, PP, FDE, cold tar epoxy, cold tap. I now understand that you remember all this terminology or acronyms, what I'm using now. That gives the confidence to me that you know the coding subject, what I have already uh, passed. Other plate structure pipe, coating with inorganic zinc silicate shop primer. This is nothing but is a transit primer by which you can ship such particles to different areas and then do final coating at the end where you want to do a lot of dress ups and welding at site. There are certain specialized coating also there, TSA coating or switch, water treatment tank, pits, food grade or potable water storage tank. Then marine industrial, that is seafarers, rigs, coating for with anti-fouling. What is mean by anti-fouling means there is no bacterial growth going to be there at that surface, because when ship is parked, it is always having seawater and certain uh, bacterial growth which is there at the surface of water to air. So this is what we have to know. Coming to the photographs or the articles, this is what the fireproofing area. So you always find different coating systems. So if you see skirt, epoxy phenolic coating, that is cementitious fireproofing, that is always for fireproofing applications. And rest of the paint, that is for inorganic zinc silicate and silicon aluminum. What I say, it is for 400 degrees centigrade temperature resistance applications. Similar way is a structure, is a normal environment where you can apply zinc silicate followed by high build epoxy, then aliphatic polyurethane coating for any oil and gas structures. If you have a pressure vessels for 120 degrees centigrade temperature range, you can use zinc silicate or zinc rich epoxy primer, high build epoxy, aliphatic polyurethane for the color. Similar way for under insulations, say for 200-degree temperature, you can apply this. Cleats are indications that there is an insulation over this particular vessel. So you can apply epoxy phenolic coats, which is high temperature resistance. This is all high pressure flare area. This is all the lines and this is all the pipings which we see. So this is always at high temperature, 540 degrees centigrade. The paint is silicon aluminum. This is for the stainless steel stack because the chimney is always operated at high temperature. So structures are always withstanding high temperature. So carbon steel can restrict up to 450 or 425 degrees centigrade temperature. So normally these structures are of stainless steel. This is the skid mounted motors and other piping structures that is normally used for different painting system. You can see the yellow paint system, white, and the different color systems for motor. So this is all based on different coating systems choose for single particular applications for oil and gas process skid package. Similar way, the structures yellow coated is for the walkways or the persons can walk at that point, and other is a process vessel structure. So that is painted in the different color. So this is how we can identify columns with pipe rack structures, which is this, and handrail and ladders, which is lying here. So this is how the systems can be evaluated. This is again a tank pump. That is what the same philosophy is shown here. Similar with 3LP coatings, how it looks on the pipe is like this. Fusion bonded epoxy from inside and outside. You can see very good photographs here. This is just a feeling for you to know how the coatings looks like. This is coal tar epoxy coating is a black in color, how it is applied and then how it is applied at the shop and how it is applied at the site. So how it's the colors are different at different applications. This is polyimide cold applied tap coating. So this is different than the coal tar. Is the tap is manually applied by applications of the coating. 50% overlapping, of course, is there. This is about the cementitious fireproofing requirements. This is how the coatings are applied. 1, 2, 3, 4 layers, steel surface, primer, intumescent coating and top coats. After fire, you can see is like this, is get expanded. So it is protecting the structure so that the temperature won't reach to the structure. So this is after fire, how it looks like. So thank you very much. This is what the things I want to convey. I'm happy to answer a few questions now and during session. Over to.
Okay, thank you very much, Urvesh. And first of all, if you'd like to just give some thanks to our sponsor, Preserve and Institute of Corrosion, that would be ideal.
Thank you. And thank you, Institute of Corrosions, for providing me such opportunity to share such wonderful sessions on codings, which definitely helpful to all the participants. Thank you.
Okay, so we've the committee has managed to collect a couple of questions for you, so we're just going to ask them now at the end of the session. So the first one would be based on what you said. What would you say is the life expectancy of a given coating?
Yeah. So the life expectancy is based on the product form. For example, if you have a piping, if you have a heat exchanger, if you have a vessel, if you have a column reactor. So all these components having different life. For example, piping is generally 10 years. Heat exchangers is 15 years. Column heat exchangers 25 to 30 years. So based on this durability, you have to select the proper coding system so that you can choose proper life of those components based on the design life of your job. So that is what we have to go through ISO 12944-5 requirement. And if you go through that, you will get the dry film thickness requirement. I just give you one example. Higher the thickness, higher the protections, and higher the life of the coding. So this is a one thumb rule which we can just have for our coding. But this is not a generalized statement. So please take concurrence from any paint manufacturer for the DFT if it is crossing your limit. So that is to be taken care by you always with the help of the data sheet given to you. So there they specified the minimum dry film thickness required for that particular paint pigments. So follow data sheet requirement, which is there on the paint manufacturer box.
Thank you very much. Okay, the next question we have is why is it so important for oil and gas operators to utilize the codes, the painting codes in question?
Yeah, it's a good question. See, the thing is why we want to go for such different coding systems for, say, above ground and underground applications. So this is based on various categories requirement. First is the temperature. Any coding system, what we select, that is selection is based on the temperature. So normally coatings are selected based on the maximum operating temperature requirements. Also, it is to be taken care for steam out temperature. There are many examples where steam out temperature is higher than the process fluid temperature. So then in that case, you have to consider steam out temperature, which is almost 120 degrees centigrade to 150 degrees centigrade temperature. So this is what the requirement. Second is based on the corrosivity of the environment. Third is the surface preparations, what you do for the coding. And the last one that is based on the DFT which you assured or the contents which you choose based on the types of coding which you choose for your applications. Just to summarize, if you have a multi-code system, is always good system for you to have a more resistance layers, which is act as a first line soldier, second line soldier, and third line soldier. So zinc base is always by sacrificial. Aluminium is again the second layer of requirements. So zinc followed by aluminium pigments coating, it's giving you a longer life at high temperatures and it's give more durability with respect to environmental corrosion.
Okay, thank you very much. Next question we have is, so these current standards, which other industries within the energy transition would they apply to? They apply to offshore wind? Would they apply to nuclear? Would they apply to solar, for example? Any idea?
Yeah. See, the standard which is ISO 12944-5 that is applicable to onshore structures. Offshore structures, there is a different standard which is altogether which tells much about organic coatings. So it is not listed much in ISO 12944-5, which is onshore coding applications requirement. But of course, yes, onshore or offshore under insulations, there is a standard which is called NACE SP0198, which is normally used for the insulation applications. So just to summarize your question answer is yes, for onshore or offshore above ground structures, you can refer ISO 12944-5 requirements, and for corrosion under insulations or under insulation and fireproofing, you can use NACE SP0198 standard.
Okay, thank you very much. We just got a couple of more questions from our committee here. So the first one is, what is your view on thermally sprayed aluminium type coatings for offshore service? They don't appear to be mentioned in your slides.
Yeah, thermal spray aluminum is my research topic. I can discuss in length, but just to summarize you, that is thermal spray aluminum coating and thermal spray zinc coating. These are the two variants which we can apply with the two method. One is a flame, other is an arc. So these two methods are more popular in normally offshore platforms. Aluminum always there for the corrosion resistance property. Zinc of course is there, but zinc can give you more corrosion resistance based on the seawater environments, whereas aluminum is always there for high temperature applications for thermal coating. So TSA or TSZ is the acronyms normally used for such coatings, and this having the category which is more than 25 years life of any coating. And the DFT, that is the thickness, dry film thickness or the thickness of coating that can be achieved in the range of You can apply multi-layer coating with this for enhancing any component life. Just to add in this that TSA coating can be applied to already constructed structures with the help of hot dip galvanized steel. So hot dip galvanized steel structure cannot be replaced by hot dip at site. It is always to be rectified with the help of TSA coating.
Thank you very much for that. Okay, and we have one more question. So we got an observation here. This is a long question, so bear with me. So it says, in relation to 3LP coating, you mentioned overall very good corrosion protection, and then only go to say that 3LP shall be used with cathodic protection. Of course, no coating system is ever 100% perfect, especially on buried pipelines. From recent reports, there appears to be great difficulty in measuring CP potentials accurately for these type of coatings due to the way they behave electrically. Do you agree?
Yes, I agree. Just to clarify more is 3LP coating is applied in the shop. So a lot of care is there, a lot of automations is there. So there are less holiday. But yes, of course, when it is laid down, because of the laid down processes, there is a certain area where the holidays are observed. Sometimes it is addressed and sometimes underneath or at the bottom at the 6 o'clock positions, it is difficult for us to even visualize where we are letting down the pipelines. So those areas where the corrosion start faster. But yes, of course, because of its property and the area ratio effect of galvanic series, and there is a secondary protections that is called cathodic protections. The lines get protected for longer life. But of course, the scratch resistance or indentation resistance for 3LP coating is excellent among all the coating types. So I can say that if the layers are damaged, but that damage is not much to the last layer. And of course, it's give you a good life of 3LP coating because it's the best coating out of all coating categories.
Excellent. Thank you for that. And just one more query. If anyone would like to contact you about any further work or clarification on anything in this presentation, how can they reach you?
Yeah, they can reach me by my name, Urvesh Vala @lntchiyoda.com. So if you can write mail to me, or even I'm requesting Institute of Corrosions to provide my credentials to the participants so that they can reach out to me. Thank you.
Okay, perfect. We'll do that. And in case anyone has any questions, please let us know and send them to the ICOR Aberdeen Gmail address. We'll be able to forward them to our presenter on your behalf. And hopefully we'll have a follow-up session thereafter where we can address them for you. Okay, so
Yeah.
I'd like to take this opportunity to thank you very much for your presentation today. And thank you very much for supporting this event, Annual Corrosion Forum this year and the Energy Transition Forum, and very much appreciated. So on behalf of everyone that's listening, thank you very much.
Same here. Thank you. Thank you, Institute of Corrosions, for providing me such opportunity so that I can interact with a lot of people like this by this platform. And I'm happy to continue my contributions to Institute of Corrosions for future events. Thank you very much.
Thank you again.